Hello guys, welcome to another video from Theory channel. In this video, we're gonna solve the third exercise from Michael Sipser textbook, and actually in this exercise, we're gonna review the principle of context-free grammars. We're gonna review variables, terminals, the rules that we have in context-free grammars, and other things. And I hope you guys enjoyed this video, and let's solve it together. Okay guys, as you can see here, this is the question number 3. Answer each part for the following context-free grammars. So this is the grammar that we have here, and we have actually some rules here. Actually the variable r will return x r x or s. The variable s will return a tb or bta, and the variable t will return xtx or x or epsilon, and variable x will return a and b. So first, before that we start this practice here, let me review something with you guys. And this is the part of the actually Michael Sipser textbook that we have here. Actually, if you take a look at this part here, this part, if u, v, and w are strings of variables and terminals, and a this part we will say that we have this rule in our rules for context-free grammars, and we say that a will return w is a rule of the grammar. We say that uav yields uwv, written as uav yield uwv. So if we can achieve some string in only one step, we will say that it will yield this string. But after that, we will see that say that u drives v written as u star v if u is equal to v, or if a sequence u1, u2 until uk exist for k greater than or equal to 0. And we have some steps here. Actually, we have k plus 1 steps here. We must actually retrieve some string in some steps that are greater than or equal to 0. So if we achieve some string in one step, we will say that we yield this string. But if we achieve some string in 0 step or greater, actually derivatives is a greater abstract in the context-free grammars. We will say that u will derives v. So after that, I write the part of the actual question here. So let's review that. The first part is that what are the variables of g? So based off this grammar that we have here, we know that the actually alphabet that we write them as caps lock. So these alphabet are caps lock, so they are big, and we call this alphabet the variable of our grammar. So r, s, t, and x is the variable of our grammar. So we have x, r, s, and t. These are the variable of our grammar here. So yes, that's it. And after that, actually, let me close this page here. Yes. The second question is that what are the terminals of G? So the alphabet that we write them with the little actually language, like this little a or little b here, these are the terminals of our grammar. And we have only a and b here. And notice that the epsilon is not a terminal of our grammar. Epsilon is actually another part of our grammar. We say that our grammar will derives epsilon, but this is not a terminal of our grammar here. So we have a and b like this, and after that the third part is that which is the start variable of g. And notice that the first variable that we write in our rules, actually here this is r, is the start variable of our grammar here. So we will write r here, and after that, for the fourth part, give 3 strings in language G. Okay, give 3 string in LG. So we have these rules here. Actually, we must write 3 string that we can achieve them in our context-free grammar. So here we can actually we have three strings. So first, let me change the color. Yes, the first string is that we will start with R, and after that it will yield somehow XRX. You have this rule, and after that R will return actually S, XSX, and after that S will yield actually ATB, XATBX, here like that. And after that here X will yield A, first X, and we have A after that, and T, actually T, and after that we have B and another X. And after this part, we know that T can yield epsilon. So we will write it like this, actually. A, and after that we have another A. And after that we have B, and after that we have X. And in the final part, X will return B. So this is the first string in our language. The second one, actually look at this step here. In this step, X will yield B. So we can change it that somehow that X, we want to X be the alphabet A. So we will change it and it will become like this. A, B, X will yield A, B, A. So this is the second string in our language. And the last one, actually, we know that from this part here, actually, we have X, A, T, B, actually like this, and X. And after that, we can change X here, and we want to replace it with B. So it will become like this, BATBX, and after that, T will yield epsilon, so it will become like this. And finally, X will yield BA. So this is the first string here, this is the second string, and this is the third string here. So these strings are in our language. And for next part, we have give three strings not in LG. So if you look at the string here, we know that epsilon and A and B are not in our language. Because if we start from R, we have two options. We can replace it with XRX or S. If we replace it with XRX, each of X will replace with A or B. So we don't have actually L1A or single B here. But if we replace R with S, after that S will return ATB or BTA. So in this step, we don't have single A or single B or epsilon. So actually, in this part, we can write A, B, and epsilon. It will become like this. Okay, and after that, for the next part, true or false, T will yield A, B, A. So if you look at this grammar here, we know that T cannot yield XTX, because if we want to yield some things, we must achieve that in only one step. So this is not correct, and this is false here. So this is false, actually. Yes, this is false. Okay, and for the next part, we have true or false. T will derives A, B, and A. Actually, this part here is correct, but how? We can use these rules here. We know that T will yield, actually, let me fix it. We know that T will yield XTX, and after that we know that T can yield a single X, so it will become like this. And after that we can replace each of x with a or b. So it will become ax x, and after that abx, and after that aba. So this part here is correct. And for the next part, actually we have true or false. T will yield T. Actually, this one is not correct. So because based on the definition, we know that if we want to yield something, we must achieve that in only one step. But we cannot achieve T from T in only one step. So this is not correct, and part H is false actually. So we must write that this part is false. Yes. And for the next part, we have part I, true or false. T will drive T. Actually, this part is correct because based on the definition that I show you, the principal drives is something like that. If U drives V, we have two options. The first part is that U is equal to V, and the second part is that we must achieve V from U in k steps that k is equal or greater than 0. So actually this part is correct. So yes, this part is true. Actually, yes. And for the next part, part J, true or false, x will actually drives a, b, a. And this part is also correct because we know that we can replace each of these x here with a or b. So this part is correct. This part is also true. Yes. The next part is that true or false. X will drives a, b, a. So if we look at this part, we know that based on this rule that we have here, actually based on this rule, we know that x will only yield a or b, and we cannot somehow expand it to a, b, a. So this part is false. And for the next part, true or false, T will drives x. Actually, this part is correct because we know that actually T will yield x, and after that we can change T with epsilon. So we can achieve x. So this part is correct actually. This part is true. The next part is that true or false. T can drives x. So for this part, this is actually like the last part that we saw, like part L. First, we will achieve x, and after that, we can replace t with another x. So we can achieve x, and x. So this part is also correct. And the part N says that S will drives epsilon. Actually, if you take a look at this part, the rule for S have two options. It can yield ATB or BTA. So if you follow each of these rules here, there is A or B in your string, so you cannot achieve the epsilon string, and this part is not correct. So this part is false. And for final part, give a description in English of language G. So here, actually, if you take a look at rules, for the first part, we have two options. We can replace R with XRX or S. If you follow the first part, XRX, in each part, you can replace X with any language that you like, A or B. But for the part R, we must in some step replace R with S. Actually, and after that, S have two options. It can yield ATB or BTA. For each of these parts, we know that B is not equal to A and A is not equal to B. Actually, if you take at this string here, T actually can be anything, because after that in this part we will reach T, and T can be epsilon, x, and we can replace it with another x, so T can be anything. It can be A, it can be B, and other things. So here. Okay guys, so if you replace it with anything, so you have some part in your string, or better I say language, that if you cut this in two parts that we call this part A and part B, there is some point that the first part is not equal to the second part here. So actually we know that this is the definition of the palindrome string. If we can find the actually place that we can cut our string that the first part is equal to the second part, we will say that our string is palindrome actually. But we cannot find any place in our string that if we cut it, we reach this condition. So actually this language here will actually create all of the strings that are not palindrome strings. And this is a description of the language LG. And yes, that's it guys. This was the full answer for the third question in the Michael Sipser textbook. I hope you guys enjoyed this video. If you have any idea or opinion for me to become better in my work, you can leave them in the comment part. If you like this video, like it. This is a big motive for me to improve my channel. And if you notice that I upload this video after a long time, so this is a very big actually motivation for me. And if you like this, all of these concept of my channel is about algorithm, computational theory, and other things that you can find out in computer science or computer engineering. So if you can subscribe to my channel and ring the bell for the notification. And that's it guys. Have a nice day guys. Goodbye.